We are on our way to Euclid Book 1, Proposition 47, but this is not Euclid Book 1, Proposition 47. This is Euclid Book 1, Proposition number 35. So I'm going to say this one more time. You are now watching Euclid Book 1, Proposition number 35. Now, Euclid wants you to draw two parallelograms. The first one is A, B, C, D. Okay? And then the second one is B, E, F, C. Okay? Now, the first question that's going to come to your mind is, how do I draw these two parallelograms? Alrighty. Let's take a look. Now, if you'll remember back in a previous proposition, you have a line here, like this, and another line here, like this. These are two sides of a triangle. And then this little invisible line is a third line, okay? So from that third line, what you're going to do is you're going to duplicate this length right here, this base right here, right up here. And then you're going to duplicate this line right here, right down here. And then you're going to strike two arcs. And if you'll remember from Euclid Book 1, Propositions number 22 and 23, when you strike those two arcs, now I'm using a substandard compass. If I had a real good compass right now, it would be a lot more accurate. But if you use a real good compass, when you strike an arc with center here and outermost edge here, strike one arc, and center here and outermost edge here and center here, and strike yet another arc. Where those two arcs meet, you'll draw this line, and when you do, it will be the same length. This line right here will be the exact same length as this line right down here, and that will make these two lines not only parallel but also equal. Okay? And then what you would do after that is you would just draw another line from here to here, and you'd have your parallelogram. Okay? So once again, you're going to duplicate this length right here, and you're going to use propositions number 2 and 3 to do that. You're going to duplicate this length right here, and you're going to use propositions 2 and 3 to do that. Once you do, you're going to strike arcs. Center here, outermost edge here, right up here. Center here, outermost edge here, right up here. Where those two meet, you're going to draw a line from here to here, and that length will not only be equal to this length right here, but it will also be parallel to that length right here. Alright, now to create a less messy environment, we just went ahead and used our ruler. I could have used this method, but I would have needed a little bit better compass, and I don't have one right now, and I will be getting one, and hopefully these lines will be a little more accurate. Alright, so using the substandard equipment that I have, let's just get on with the proof. Again, we have two parallelograms, A, B, C, and D, and then we have parallelogram B, E, F, and C. Okay, now, what is Euclid trying to prove? Well, he's trying to prove that parallelogram A, B, C, and D is equal in size to parallelogram B, E, F, and C. How does he do this? Well, he gives us a few things. Alright? First of all, he told us that we had to draw our parallelogram. Okay? Now, because A, B, C, D is a parallelogram, AD is equal to BC. Well, here's AD here, and it's equal to BC. And we proved this in Propositions 134. Okay? So, by Proposition 134, AD equals BC. And then again by Proposition 134, EF is equal to BC. Alright? Now, we can also say by the transitive property, since AD equals BC and EF equals BC, that AD equals EF. Okay? Now, what would happen if we add the length of DE to AD and the length of DE to EF? Well, then suddenly the length of AE would be equal in size to the length of DF. That's just the way it is. Okay? Now, again, by Proposition 134, we have the length of AB suddenly equaling the length of DC. Okay? That's because this is a parallelogram. So that length is equal to that length, 134. Now, because we have this, and this line right here, this AD line, is a line that drops onto, let's get on here. This line AD drops onto the two parallel lines AB and DC, and you could tell this if you were to extend these two lines out. This line lies on top of them. Then we can finally say that angle FDC, and angle EAB are equal. Okay? And this is due to Book 1, proposition number 29. Okay? Now, because of this, we can actually say that we have two triangles, DFC and AEB. And these two triangles are now equal in size because of the side angle side technique. Alright? Now, because of all that, EB is equal in size to FC. Alright? Which we could have said that anyway, because in a parallelogram the opposite sides are equal. But we're saying that because this is now a triangle. Alright? So EB equals FC in size. Therefore, I know that's a lot of stuff right there. Alright. So we have two triangles, EAB, DFC. These two triangles are equal in size. Now we're going to subtract a portion out of both of those triangles. And when we do, we're going to form two trapeziums. Okay, now I'm sure if you look this up, you'll find out what a trapezoid is. So now you have two trapeziums. The first one being DABG, and the second one being FEGC. And they're equal in size because if you subtract the same amount from two different things, it's going to be the same amount, especially if those two separate things were already equal in the first place. Alright, now to make a long story just a little bit longer, we've now established that the two trapeziums ADBG and EFCG are equal in size. Well, we're going to add something to both of them that's equal in size, which is the triangle GBC. And if we add the triangle GBC to trapezium ADBG and trapezium EFGC, and I know that's a lot of letters. Well, you're learning your alphabet now. Now you know why you had to learn the alphabet. Okay. So we had a trapezoid here, we had a trapezoid here, we added the triangle GBC to both of them, and when we did, we finally said, here we go, that parallelogram ADCB is equal in size to BEFC. And that's what Euclid was trying to prove in the first place. That's a long way to go about it, but now you know. Alright, if you have any questions, just leave me a comment down below. Hopefully I didn't get you too badly confused. And wait till you see Euclid Book 1, proposition number 36. Man, are you in for a treat. Bye.